Good life, everyone. This is Nikki Lois Diana about to discuss decision theory and analysis with my partner Patricia Aurelio. So we've all noticed that in our everyday living we've been in a situation where we're stuck between choosing what to do best or choosing which option would lead to a better result, and in a situation where critical decision making is involved and that requires a very deep analysis, and the fact that the business world is never an exception to these kinds of situations. So we've noticed that in the previous topic, linear programming, models were formulated and solved in order to aid the manager in making a decision, and that these decisions or these models were all formulated under the assumption that certainty existed because there were certain variables assigned to them. However, in actual practice, many decision-making situations occur under conditions of uncertainty, and there are techniques that are available to aid the decision maker in dealing with this type of situation in which there is uncertainty. So decision situations can be categorized into two classes: situations in which probabilities cannot be assigned to future occurrences, and situations which can be assigned, or situations which probabilities can be assigned rather. So a decision-making situation includes several components: the decisions themselves and the actual events that may occur in the future, known as states of nature. The states of nature are good economic conditions and bad economic conditions, and the states of nature that occurs will determine the outcome of the decision, and it is obvious that the decision maker has no control over which state will occur. So I have mentioned earlier that there are criteria, techniques, concepts, or models that will aid the decision maker in making these decisions. So the problem presented is given to us by our instructor and requires the computation of expected value for each decision and expected opportunity loss, together with the opportunity table, which will be presented to you later. So to facilitate the analysis of these type of decision situations so that the best decisions result, there are organized into payoff tables. So basically, payoff table is a means of organizing and illustrating the payoffs from the different decisions given the various states of nature in a decision problem. So there are two types of decision making with probabilities and decision making without probabilities. So in this case, it's a decision making with probabilities. So this is the problem. A concessions manager at the Tech versus A&M football game must decide whether to have the vendors sell sun visors or umbrellas. There is a 30% chance of rain, a 15% chance of overcast skies, and a 55% chance of sunshine, according to the weather forecast in College Junction where the game is to be held. And the manager estimates that the following profits will result from each decision given each set of weather conditions. So for sun visors under the rain forecast, it will have a loss of $500. Under the overcast forecast, it will have a loss of $200, and under the sunshine forecast, it will have a gain of $1,500. However, the umbrella under the rain forecast will have a $2,000 gain, zero balance in overcast, and a loss of $900 under sunshine. So it is often possible for the decision maker to know enough about the future states of nature assigned to probabilities to their occurrences. Given that the probabilities can be assigned, several decision criteria are available to aid the decision maker. It is often possible for the decision maker to know enough about the future state of nature to assign probabilities to their occurrence, given that the probabilities can be assigned and several decision criteria are available to aid the decision maker. However, before we say the criteria, the concept, or the models assigned to these problems, we are first going to tell you the problems identified by by myself and my pair. So the first problem would be, between umbrellas and sun visors, what should the vendors sell at the football game? Second, which of these two products will yield a favorable result? And three, what is the expected value based on the given set of data? And the last is, create the opportunity loss table with the expected opportunity loss. So these last two problems will identify the answers of number one and number two, and will also give the sellers recommendations and advices whether to sell these products or not. I have mentioned earlier that there are criteria, technique, model or concept that will aid the decision maker in their decisions. So these criteria that we selected are the expected value and the expected opportunity loss. So to apply the concept of expected value as decision-making criterion, the decision maker must first estimate the probability of the occurrence of each state of nature. So once this estimate has been made, the expected value for each decision alternative can be computed, and the expected value is computed by multiplying each decision outcome under each state of nature by the probability of its occurrence. So this presented here is the computation of the expected value of a random variable x. So this is written symbolically as and computed as summation of n, where n is the values of the random variable x. So using our vendor problem, let us suppose that based on the weather forecast in College Junction, where the events will be held, a 30% chance of rain, a 15% overcast skies, and a 55% chance of sunshine will prevail. But before the computation, we will first extract the variables needed, and Patricia Aurelio, my partner, will discuss this part of the problem.
So for the variables, these variables, we can use this to solve for the expected value, expected opportunity loss, or even make for the opportunity loss table or the regret table. So the given are, there are 30% chance of rain, 15% chance of overcast, 55% chance of sunshine. And on this table, this is the estimated profit that will result from each decision given each set of weather conditions. Solution. Step 1. Compute the expected value of each decision. Again, expected value is computed by multiplying each decision outcome under each state of nature by the probability of its occurrence. So let's solve for the expected value of the sun visors. When it is raining, the outcome is negative $500 with a probability of 30%. And then when there is an overcast, there is an outcome of negative $200 with a probability of 15%. And then when it is sunny, there is an outcome of $1,500 with a probability of 55%. Multiply the decision outcome and the probabilities, so we get negative 150, negative 30, and 825. We just add it all up, so we get $645. We will do the same with the expected value of umbrellas with its given decision outcomes for each state of nature and its probability. Step 2. Compare and select the best expected value. So for the sun visors, we have $645, and for the umbrellas, we have $105. So since the sun visors has the highest expected value, so we will choose sun visors for the best expected value. Step 3. Develop an opportunity loss table or regret table. We will be using the mini-box regret criterion here. We'll first select the maximum payoff under each state of nature. So each state of nature are the weather conditions. So for the first weather condition, which is rain, The maximum payoff is $2,000. For overcast, it is 0. Sunshine, it is $1,500. After selecting the maximum payoff under each state of nature, we then subtract all other payoffs under this respective state of nature. So the maximum payoff for rain is $2,000. For overcast, it is 0. For sunshine, it is $1,500. So let us now subtract all the other payoffs under this state of nature. So the values are now shown in the slides. Those values are called regret. Then these values, we can use this on making an opportunity loss table shown on slide 15. Step 4. Compute for the expected opportunity loss. Expected opportunity loss is the expected value of the regret for each decision. To compute for expected opportunity loss, we multiply the probabilities by the regret for each decision outcome rather than multiplying the decision outcomes by the probability of their occurrence as we did for the expected value. We will now compute for the expected opportunity loss for the sun visors and umbrellas. We can use the opportunity loss table for computing the expected opportunity loss. So it was given in the table that the regret for the sun visors when it is raining is 2,500. For the outcast, it's 200. For when it is sunny, it is 0. So again, we multiply it with the probability of their occurrence. So for the sun visors, we get $780. For the umbrellas, we get $1,155. Answers. So for letter A, compute the expected value for each decision and select the best one. After we computed the expected value of each decision, sun visors has the highest expected value of $645. We then conclude that the sun visors is the best decision.
Recommendations. From what we have computed, it is shown that the sun visors have the highest expected value and the lowest expected opportunity loss. So we recommend the concessions manager at the Tech versus A&M football game to sell sun visors at the College Junction instead of umbrellas.